So, we should have started 5 minutes ago, and I will start speaking for those who are here already. And I will tell you how to use the asyncio. I'm the Python core developer for 20 years. I've been participating in the asyncio code, one quarter of it, and aiohttp is for synchronous code, and also a number of the asynchronous libraries at the lib. So what is asyncio? In short, who has been looking into Python 2 and Jumbo? Asyncio is a library that is 6 years old. It is quite mature, if not old. Recently, in the past couple of years, asyncio is getting popular, higher the agenda, because it can address quite a number of the issues in real life, but on the other side, it is something new, interesting, so why not use it? Asyncio projects are growing quite rapidly. And it's a new technology, new platform, and the programmers fancy new things. And another reason why it is getting popular, because it is used for networking programming. Hold on a minute. So it is used for asynchronous programming. It means that one processor can process a great number of the both incoming and outgoing links, and if there is any bottleneck with the input-output, then asyncio can help you. It is very fast, and fast enough, for example, to aiohttp to have been employed by a Rambler, and all the traffic is being used. Such systems as voice over IP use asyncio, the telecom providers and others. It is quite good for Python. It is possible to write something faster, but it will be a different thing. So anyway, it is performing well, it is stable, and it is reliable. Asyncio has been developed by a qualified person. I do not mean myself, but Van Ross, and the architectural solutions were chosen meticulously, analyzing Twister, Tornado. They were processed, and they got what we have now. aiohttp, it is both a client and a server to using the HTTP protocol, using the websites and connecting to the other web clients. It is older than the asyncio, but younger. It was used when asyncio was referred to as tulip, and so then they split the two things. And as I said, their performance is quite good. If anything, I will during the Q&A we can discuss the performance. Here is a map of the visits to the documentation site, and you should be proud. Russia is number 1 together with the US, and the Ukraine is sharing number 3 and 4 with China. The others are behind. That's how the code looks alike. It is a function, and to show that it is asynchronous, we write asynchronous def instead of def, and then we insert a await. The rules are simple, and it is very attractive. We don't have to write deferred, future. You just stick async, await everywhere, and it works until there are specific problems. And these are the problems of not async IO as implementation, but of an asynchronous approach on the whole. Let me explain what I mean. The Python programmers are subdivided into two. Those are doing data science, and the others are doing web, and the rest, which could be disregarded. Those who are doing web do it conventionally. It is a protocol, Flask, Django, Falcon. You just choose your favorite one, and then when the view is called, your header is called, it will never be interrupted. You have to answer it fast, and all the problems of the continuous links which are not reliable, that get broken, that have a timeout. Until recently, the Python programmer was not aware of them, and there were marginals of twist or tornado freaks who were dealing with those. But since the asynchronous approach is getting popular, all the programmers will have to get acquainted with those difficulties. So if we are called up asynchronously, we do asynchronously as well. And then we take the page from the Python site, and it will be processed automatically, and you will get the HTTP text. Everything is quite clear, and if you see async with, it is something that is being done asynchronously. How is it done? The details of how it is rolling, what is a coroutine, is quite interesting, but just a limited number of people will have to know it. It's not just it is a secret that is being concealed. No, we are talking about superficial things, but what we do need to understand, await G inside the asynchronous means the point yield points, and the program works from await till await. It comes up to await, and the control could get over from one problem, switching between threads, and the Python switches between the threads when the operating system decides so, and the switching between the asynchronous problems is done at awaits. It is not a guarantee that there will be a switch over. It's just that it might happen over there. We read the data from socket, we take up 5 bytes, or better 6 bytes. If those bytes are in the buffer and nothing should be done, there'll be no switching of controls. It will just get back. If you have to stand by to wait, then we will wait. But not for all. That was obvious. But that it doesn't affect anything. You just have to understand that the switching could happen or not. We have three pieces over here. The first one till the second one, then between the second and the fourth, and after the fourth. This asynchronous function could be interrupted potentially twice. What are the benefits? What does it give us? Or what are the concerns? If the codes is being implemented between awaits, then it will be necessarily implemented in one piece. There is no interlocks to be introduced. The switching is done in particular points. Another thing, if there is a long synchronous call between awaits, everything will stop for this time. And it is not a death for asyncio, but your program will not work. Under the load it will be slowed down, and it happens after the synchronous, because of the synchronous code. I will tell you how to cope with that. And 3, it is not an obvious effect, but it is very important, because we have 2 switching points over here, and one can test it pretty easily. You can cover it with tests, and formally the complete coverage of the multi-thread code is not possible, because it is very difficult to switch the tests at each instruction. But in the second, there will be unlimited number and unit tests for multi-threaded codes. They check the logic, but they are not complete. They cannot, by definition, and they cannot be complete, and much depends on the talent of the programmist, by its gut feeling. Blocking calls. Here is async function, and we calculate p till sign 5. If it is too fast, then you add 4 zeros. What's happening? The async program is rolling in the event loops. It is a thing that is communicating with the sockets. It is responsible for the timeouts, for timers and other things. And the whole machinery stands by while the PI is being calculated. No other code it works. If it is a web server, then while we try to get to show the PI to one client, the other clients won't be seen whether they access or not. So, to resolve it, for asynchronous things, we have thread pool. It is in the Python, in the other, and we tell them execute our function with that kind of parameters and await till the execution. And so this particular await tells us that there was a synchronous function, and now the event will be in the thread pool, and our principal thread, event thread, will be executed, and the other lightweight tasks will be executed as well. So, talking about the threads which are referred to as tasks, we have a fetch function, we have a main function, and we create tasks, and each task fetches its own, and we put them into a list, and we tell them await all. That's how we get rid of the multi-threaded execution. And that's what all programmers know. Python debug mode includes the debug mode, and our xpy file will be launched in debug mode, and you will see a lot displayed at the console. And this garbage is not unnecessary, not useless. And it will tell you if you have not seen an exception or some synchronous code is slowing down. It is 1/10 of a second, or something is happening that makes asyncio suspicious. The debug mode switch on the logging mode. I hope you know setup tools, entry points, and you do not launch the Python files at your main file. Packages should be done, and they should be set up correctly, and only then you will be able to write a script in one file. But what will we get our money for?
So we are through with the introduction, and now more sophisticated things are coming. So the network and timeouts are interconnected very closely. So if we have a program doing something about the sockets, then we have to think what is to be done about it, because the network may break down anytime. I mean, anytime when you want to sell something, your machine may be working okay and you can't see it, then you test it, everything seems okay, but once the users come, timeouts start. So a reliable network, it differs from the reliable one by the number of breakdowns. So it's important to understand when the network starts breaking down, starts failing. And it is also important to understand why with TCP or IP network it is an inborn property. They were made in such a way that they can be recovered after a failure. Well, we have heard about this message that they would perform even after a nuclear explosion. However, the peculiar thing about it is that if a server breaks down, possibly due to a blackout, or maybe something is wrong with the connecting channel, you might get a message about it, a message about this event, but chances are you will not get it. I mean, you may only get it after 2 hours, when the default time expires, and this is too long a time. That is why in all of the network interactions there are their own timeouts, and they are numbered, they're counted in minutes and not hours. So speaking about timeouts, what is the simplest way to do it? Well, we take something here, we read the content of a page, and then we wrap it in a timeout. I think we will have enough time. With asyncio, there is its own box for this purpose, so it's a bit slow and a bit less convenient, but you can still use it. It does work, and it looks quite clear. Everything is okay, but for one exception. I haven't come across a single person who knows how to accurately install timeouts. We all forget about it. Even though there may be an apparent timeout, then what is to be done? Timeouts need to be built into the libraries. I do hope that none of you will ever have to write their own library to enter websites. I hope for this because I tried to do something about it, and I have been dealing with it for 4 years now. And the more I get into it, the better understand that those were just illusions that I had. It is damn hard to deal with this protocol and this logic. And when we are to comply with an order for a customer, we use ready-made libraries. And those ready-made libraries, no matter what they are intended for monkeys or any client, for Amazon, for Elasticsearch, etc., doesn't matter. All of them need to have a reasonable timeout under the hood, which can be used by default or can be adjusted if something goes wrong. And only this kind of approach works. Otherwise, as I have already said, all of us forget about it, and I have been forgetting about it myself too. Now, speaking about timeouts with spawn tasks, as you can see with async network, which has a number of tasks, and here we can see an evident timeout around the reader. And as a matter of fact, there is a timeout built into the client, but this one is more graphic. And what happens if one of the websites start failing? In this case, everything is going to break down, because the timeout goes upwards, then gets to the gather, and then there is an error, and this results in a higher level of exception, higher and higher, unless we apply some additional tricks. For instance, if we do not throw away exceptions from spawn tasks, if we don't do relays, then we can wait to see the timeout returned by a fetcher and the other one to be returned by the page. Here we deal with retro reception. That's what we should remember about. And secondly, we use timeouts to wrap up everything. That is to say, we work till the first timeout occurs when there is a delay, and after that all the spawn tasks are exchanged because we are waiting for them, and they just add up to each other, and thus all the tasks which depend on it are added up. It's not quite an evident thing, and once a month I can find an issue at the starting floor or in my personal emails. People say that timeouts do not work, and after the very first timeout everything breaks down, and I have to explain it to the people. Everything is okay with your library, just that you don't understand how to properly use it. With timeouts, we have such a thing which is called task cancellation. Just returning to the prehistory, there was a time when asynchronization with blocks and queues with streams and sockets. We had timeouts everywhere, and they seemed to be quite convenient. We were quite happy then, but luckily it was a long time ago when the very first releases were just to be made. But one fine moment we understood that everything that we had written about timeouts did not work properly, because tasks can be cancelled and can be added up, and when it comes to task cancellation we could use non-trivial things. And that's why all of them had been implemented in a wrong way, and so everything would break down in case of cancellation. Really, a magnificent solution was taken just to get rid of them, that we could implement it in one place in the right way. Speaking about async timeout context manage. That is to say, we should put it down like this, but that was a hell of a job, and we couldn't make it. So the tasks dealing with spawn streams keep being cancelled, and nobody can anticipate it. At least the novices cannot anticipate it. That is to say, somewhere in the background there is possibly a page-long text describing what happens, but who reads the documentation, particularly when it is not in an HTML index? That's why when it comes to task cancellation, people complain about it almost as often as they complain about non-performing timeouts. I have it explained in my works. But then here is a web handler based on aiohttp, and here we have a page returned. Then during this process we write something into the DB. It could be something absolutely insignificant. It could deal with transferring money or doing anything else. And now your attention please. What will happen if the user closes the browser page or the internet connection is poor? Then all of these factors are put together at this point or at the capture of the pool connection with the DB, or during SQL command launching, and as a result nothing will get into the database. And this is quite unusual because with Jungler the work is different, and it's not allowed to interrupt a task running. But this is the problem of Tornado. Now with Tornado, people also will start suffering from it. Why is it so important? Because the network keeps breaking down all along, and we need to respond to it in some way. Sometimes we, for instance, give away a huge file of about 100 megabytes. Then the user starts looking for it and cannot wait for it to arrive and closes the page. It would be nice if the server could get conscious of what is happening. It could be quite a small file, For instance, the file is called the statistics aggregation for the last 33 years. The user loses his or her patience and closes the page. But if the user wants to pay money for the service, then he or she need to be able to press the button and get it done. At least if they pay at any amount, not even the entire amount. That's why it was necessary to choose the value. And for handling databases, asyncio shield can be used, and then this call, according to its name, will prevent the internal routine. Well, it's not so convenient. I will tell you about more convenient ways a bit later on, but the problem is there, and I do hope that you are conscious now of the problem, and I don't want to dream about not having such questions anymore, but at least hopefully there will be fewer questions. Now, AIO jobs. It's a recent thing. Once you get sick and tired of using shields, once you understand that it's normal when a user closes the page and when the connection is interrupted at the other end of the cable, that's why a new library was introduced. What are the tasks of this library? In addition to all the other tasks, instead of just using shield, we can use this fire and forget with collaborate task, and then we say, well, just do it, count it, and once it is counted, everything will be okay. But what's the problem here? If your task is broken, you won't see anything. Only in the general log or on the console you might be able to see it. So it is not processed by our code. The second issue is that, for instance, there is a million users running a million tasks simultaneously, and the server has no time to carry on. But we say, go on working, and there is no time to do it, and we need to put a limit to it. So if the approach is responsible enough, we should understand that we should not produce too many tasks. The number should be limited, even if it is a million tasks. But we cannot rely on the server performing without an end, because programming is a science and it also needs some limits to be set. And now speaking about the tasks that we can wait for. For instance, we have been waiting for a task, then we can do something about it once it arrives. But the problem is, where should we put this thing? I mean the task. We have a web handler. I will just go back a couple of steps. We use this connection. A user has come asking us to write down something for him. We can say, okay, I have taken note. But if we receive the task, we should wait for it. Say, it should be 200, okay? Then we should count the number of tasks launched, and then we should do this routine but absolutely necessary work. And once again, I would reiterate, we need to know how many concurrent streams we have, concurrent flows we have being run. And we understand that if they break down, something should be done about the exceptions. That is to say, we should at least be able to see them in our own log and not anywhere else. And in addition, there is another non-evident thing that we should separate them from the correct tasks which were delayed. We reload the server which has several transactions on it, and people have already said they want to pay for it, but we haven't had any time to process them. What should be done in a perfect world? We say nobody else will get in. I should wait for the request to arrive and the money to be transferred, and only after that I request the server to do something about it.
So all those tasks drops through drop schedule. We do scheduler, and by default the capacities, the spawn is the range is 100. So we've generated the job tasks, and the time between 0 to 5 seconds. In 5 seconds we tell the server sleep, and at this moment half of the coroutines finished, and some are still working, and they will be closed. And it's written once, and surprisingly I've been working on implementation longer, so, and as a result it is not that simple, and each of you can try it and repeat it. And if you are not dreaming of inventing all the wheels yourself, so you can borrow it. So that's how it looks with reference to HTTP server. A decorator is used, and all that thing gets into new job. You can vary it, go wider, but I think you have understood what is it for. The last, but not the least, when we have been developing asyncio, we went for the better, but some things became obvious after a few years of operation. You know, the idea of the designers look great on the face of it, but then after implementation it gets obvious that it's not that good. Sometimes it's difficult to mend it, to repair it, to bug it, because it's incompatible. It will be incompatible with the rest of the structure. The first thing, class, we assign class variable. You should not do it like that, because the event loop global is not what is needed for tests, because the tests will launch loop for one test, and then they will have to close the loop. But over here this client is linked to the global loop, and nothing works. But actually it's an issue for the authors of the libraries, and not when working for the customer. And it's not dealing with proprietary programs, and I do not know all my users, and I cannot deal with all of them. And then concealing this class from documents from everywhere and showing coroutine that you will have to wait, and it saves, because you cannot put a wait over here, it's wrong for the syntaxes, and you should put it into the right place, that is to delay the execution. It's an easy trick, but it works. And there is another thing, but you can make a wait HTTP, because to make it asynchronous, because this line is not static. I can do that, but I'd not advise this should be done. I know a lot of tricks on Python. If I feel like it, I can write a lot. But we make code for the colleagues, and it should be clear, understandable. And if you want to make it strange, there's a number of the languages. There are languages like brainfucker, and you can try different things over there and to enjoy it aesthetically. But try to keep it simple, straight and simple at Python. And another bug. It just turned out that in asyncio and the stream, there's a connection to the server, and it returns reader and writer. In one part of the interface is for reading and the other for writing. This idea looked very lucrative, and initially we thought that we should not write only, but we should read as well. But then it turned out the further the words and the reader and writer are connected, and this could be fixed. New stream, pass it through asyncio, not fast though. And what has not happened in all those years, because the authors of the library learned to live somehow, and the simple programmers work with the certain libraries. They don't have to go down to the certain level. And this is a practical case. Look, we have a stream over here. There's write and await write drain. So what happens? We make a synchronous record, and we cannot socket it. If we do that, it will get into the buffer, and it tells await something, and I will tell you what we should be waiting for. So the buffer is free, and we can write again. But in reality, it happens so that those two lines should be links, and the sound drain should be asynchronous, because otherwise it's very difficult to explain it to the server that, look, there are two functions, but you should always call them one after another without any exceptions. And in BIOS-PT we had to undo it, migration, deprecation periods, and prompts, logs, and then it was possible to remove the old version and to replace it with the new one, because you cannot at next release make Kyiv difficult for all the users. And what is the drain designed for? I've heard misconception, wrong opinion, that drain is waiting until all the buffer is gone to the socket. No, it's not true. In asyncio there is such a notion as watermarks, like the ranges of the limits. So this word is used quite often, and there are two watermarks: the top and the bottom watermark. Above the writings, when we write and write and write, drain, let us write, it does not slow this down until we get to the top limit, to the top watermark. Then await drain stops, and it waits until the volume of the limit will be lower than the lower watermark. And this is not an obvious thing. So when we do writing, it's the logical thing. Everything is fine with reading. If the data are there, we read it. But as far as writing is concerned, when we do write this particular call, now that I have told you, it is easy to understand. But please do not forget about it. The successful writing in the async IO, it doesn't mean that it gets to the other end or it got into the core. It means that it's gone somewhere. And there's no difference whether it's gone into the buffer, into the memory, or into the core, because you will have to process the bugs whether those bytes are gone or not, and whether they are gone from the computer to the router and got broken at the router or at our computer. It doesn't matter. There are millions of ways that they will not make it all the way to the server. Sending data does not mean anything. We need to receive the message from the other end. Like, yes, I have read it, I understood. And these things are noticed, and we have to recall it. The conventional users recall it when they start writing in X socket. Timeouts are needed because it is necessary to send pings from clients. If there is no ping, then for a certain period of time, you know your clients. If the client is not there for a minute, the connection is there, but there is no client. The connection should be closed. If you send something, some important thing to the client, not just anything, not just to get in touch or to show some kind of notification, but if it's some kind of alert, you will have to wait to receive a feedback from the client. If you send an important, sensitive information, and until you get to information, we should assume that it did not made it. And that changes the programming, because there are so many things where something might be broken from our code till the other side of the wire. But all networking programming is just like that. While we used the synchronous frameworks, they protected us from that kind of problems. But when we do live programming, the network programming, we will have to think about it. And they did in the async to make the life of the programmers more difficult. And another thing, close. Write a close over here. Okay, it works, it is closed, but what could be the problem? The connection will be closed at the next iteration of the loop, next line, because the write is a synchronous call. There's no await, and at the next line the writer will be in the semi-closed position, and it will not be possible to write into it, but inside it doesn't know that it is closed. for good, and it is necessary to wait. And over here there is an API like close and wait closed, and it is ridiculous because those things should be done within one call. If it is a TCP socket, it might be sufficient just to wait to have 0 seconds and then to get back. If it is this socket, the procedure there is longer and depends on many reasons, and if it is something more tricky, for example, RabbitMQ client, and to have it nice, it should tell you that I am gone, not here, then to wait for a response, and if the server does not send any message, then we cut this socket. And in 1-2 iteration, it turns out that we will have to do, and they close this synchronous, and to turn it from synchronous to asynchronous is quite different, because in all cases we will have to write a wait over here, and luckily in the async await sentences you can get garbage. Even not in the debug mode, you will see different things that come into being at the runtime only. We have 10 minutes for questions. I'm Lev from Indeco, and how can we handle the long asynchronous message? I don't understand the meaning. In handler, for example, you're processing some heavy request. It will have to be done asynchronous, right? Would that be reasonable to process it in a separate task? If you have to do something about it and then to give an answer 200, okay, there's no reason to generate a new task. And if you have to answer fast and then to do something in at the background, then naturally it's a new task. Good morning. Did I understand you right that the use of async IO eliminates the multi-thread programming in Python, with the exception of AIOG, or could it be done jointly? There is no need to launch 33 threads with the event loops in each. It's not only in GL, and it's only the matter of Python. SyncGL will be working in the same manner. Any system undertakes and is striving to have one event loop, or it is highly performing, there might be 2 or 3 event loops, and that's enough, because they are fast and they sleep, they wait most of the time at sys core. However, in any asynchronous system there's a loop pool, and all the tasks are put into it, all the tasks that are not implemented instantaneously. What do you think about the added synchronous generators and the problems associated with closing them? Is it worthwhile using them? Yes, I think we should use them, and closing it is calling a new object at the event loop. In the iOS HTTP, the runner closes it correctly, and the users of the HTTP are not concerned with it. There might be a number of the helpers that will prompt you to run this context manager, for example, until you have an error or a signal to close. And the correct initialization of the loop and closing of the loop will be consumed, and you will forget about the generator. Even if you close it not correctly, when the program is dead, it doesn't matter.
Any other questions? Thank you very much, Andrei, for your presentation. Well, are there situations when we need to understand inside a routine that consulter may get out of the waiter? Is my question clear to you? Yes. Yes, I got you. I don't know what it should be required for. Or maybe I've been doing something wrong. Maybe I should redo it because I've been having this problem. Maybe it's something else. What I mean is that if something is cancelled from the top, I can do. But what you are waiting may be done into accept, and then I can go on. But if I cancel from the top, I shouldn't do it. That is to say, to capture and await where you may have an internal routine is normal. And what something else might happen. It may happen that you need to understand whether you were cancelled because of a timeout or not. And then, once again, you may look it up in the timeout, whether it was just a timeout or it was somewhere from the top. That is to say, I could get it out of the kit. No, you need to get into the timeout context. This is the peculiarity of the asyncio design, that you may not bump your things. That's why it happens that sometimes you may say, or you may throw out something because of a broken socket. But sometimes all you can do is that you had some handler, then it was cancelled, and that's it. And that's it. And there are no other exceptions. You can only try to find it out from the context, whether you were cancelled or not. That's the way the design was made. Just in reply to the previous question, I suggest you may do soft task cancel. That's right, but once again, it's not an exception of the knowledge, but you could just check whether it was cancelled from my end or from somewhere else. Definitely. That is to say, that way it would be cancel and not exception. No, both of them. Both of them. Just another things to elaborate. It looks like our jobs with a built-in queue server. All of it is kept in the memory. But anyway, after a while, there'll be some cool things added to it, such as queuing priority. Well, actually, every transaction has its price, not even its implementation cost, but rather the explanation to be provided to your colleagues as to how to deal with it correctly. Anyway, your conscience will have to change, and you will understand that it's easy to add something without increasing the complexity. And that even if you meet the interest of 1% of your clients, that is to say, for those who need to have a full-fledged queue, that's possibly so, and that, okay, and so that they could work in a better way. Because the priorities are always quite challenging to deal with. And another question possibly beyond the scope of your presentation, for instance, if we start implementing a program step by step in the debugger, and then we start getting upwards when to run forever, what is to be done about the problem? While we want to take another step through a wait. But then you need to adjust the debugger, and with young 3.6 it sometimes happens. I don't know why. Sometimes it works. Sometimes when we don't need it, it works, and then when we do need it, well, it should know how to wait. Honestly speaking, I would not say that you are absolutely wrong. There may exist a problem here, and if there is one, then it should be repaired. It should be fixed. We've had debug tests, but it is not so simple. Well, if anything goes wrong, I will try to do something about it. If the weight breaks down, the first version was made for Elfrons, so probably we need to fix it. Is that it?